Well, welcome back. So just a small plug for our sponsors. Also check out in Slack, we have some dedicated channels for our gold sponsors. So please take a look. And I know our different sponsors are also monitoring those channels. So if you have questions or need any other additional resources, they'd be happy to provide that. I'm really excited right now to introduce Clay. Clay is the Vice President of Revenue at Flume, where he leads sales, marketing, and product strategy. Before coming to Flume, he was an early employee at Ratio, which you'll recognize additionally from the event, and founded and managed their utilities business. And Clay has a background in finance, previously served as a product manager developing tools for the banking industry. And one other little aside is Clay is one of the great data collab support, been part of it since the beginning, and it actually was back there at Stanford back in the first one in the small classroom. So I'm really excited to have him here at our 5th annual. It's a big milestone, and Clay's been with us since the beginning and avid water data supporter across a number of technology companies. So with that, I'll turn it over to Clay, and I know they have a great session for you. Oh, you're muted.
There we go. I just said awesome. Thanks, Drew. I remember when we were in that single classroom in Stanford, and just a quick comment on the data collaborative generally. As somebody that works in water technology and have now for 5 or 6 years, I'm constantly seeking means by which me and my team can broaden our water management acumen. And the data collaborative is really one of our primary venues for that, and understanding kind of the bleeding edge of water data and how that's used by utilities to better manage the resource. So if you don't mind, please go to the next slide. So what I want to talk about today, I'm actually joined by our CTO, James Fazio, who I'll hand it over to in a bit, but he and I will be talking a little bit about Flume. So a little bit about who we are and what our mission is. We really believe that you can't manage what you don't measure. Our mission is to empower people and communities to understand how we use water by liberating it and digitizing the data behind it. We often like to say that we're liberating water meter data from the pit where that meter is, and really bringing it to homeowners and utilities alike at a resolution that helps them understand it in so much of a greater way. We think that we're really kind of digitizing residential water use. Next slide. So we were founded probably 4 or 5 years ago, and this was right on the heels of a major drought, right? And despite messages, from our utilities, telling us to conserve, to save water, to be more efficient, we really didn't know where to start. Next slide. And so our founders created this smart water monitor. This is really quite a simple device. What it does is it straps around an existing water meter, and via Wi-Fi communicates with our cloud very, very high resolution water data for both the indoors and the outdoors. Next slide. And what it does is it captures this water use again inside and outside the home at a very, very high resolution. Right now, this is about 30 seconds to a minute, but with our future generation device, that's going to be down to 5 seconds. And what this empowers homeowners to do is set water budgets and more efficiently manage the resource, understand where water is being used, and detect leaks before they're catastrophic. Next slide. And utilities have really taken notice when it comes to our device, right? So, by putting these water data in the hands of their customers or ratepayers, it creates behavioral change. It makes them makes ratepayers more efficient in their water use. At the same time, these flow data on an aggregate level do so much to improve a utility's operations. By understanding where residential water users are using water, right? If it's irrigation, if it's toilets, shower heads, etc. It can do a lot to inform our utilities' efficiency work improve their forecasting, any growth planning, anything that they're doing to, address concerns around, the supply side of things, and overall just advance their planning capacity altogether. So next slide. And these are just a sampling of the utilities that we've worked with. We develop a number of direct distribution programs with utilities in California and all across the United States that very efficiently kind of put this device in the hands of their ratepayers. This is something that's DIY. It's super simple and easy to set up. Literally just straps around that meter and then connects to the homeowner's Wi-Fi. And for that reason, a lot of utilities approached us just saying, hey, how can we bring this to our ratepayers? And we've seen a lot of success with those programs. If we go on to the next slide, I can kind of talk about those successes and how we've quantified that. So really, we touch on three different partnerships here or programs that we've run. The first is with San Antonio Water System. Pretty consistently across our programs, we've seen between 10 to 20% savings against control groups after installing this device. And one of the things that SAWS really liked about it is that it did a lot to kind of appeal to those high water users. In fact, in our deployment with them, we found that found a reduction in water use of about 18% against a control group. And you can think about kind of the downstream effects of that in terms of reduced high bill complaints, kind of greater relationship between the ratepayer and their utility. We also, do a lot in terms of leak detection, right? By looking at these data on a 30-second or 1-minute resolution, we can quickly discover leaks. And it's been interesting to see how many homeowners experience pretty significant water leaks across their property, even if they're very small. In some work done with Contra Costa, we found that about 2/3 of their ratepayers discovered leaks within the first month of having the device installed. And then finally, there's this behavioral element, and I think this ties to the first bullet on SAWS as well. But by having these water use data in the palm of a user's hand, right on their smartphone, they're better informed about how they use that water use. And they may find that a certain appliance in their house uses much more water than they imagined it did. We have an ongoing partnership with Rainbow Municipal Water District in San Diego County, and there we found that almost 90% of their customers who used Flume reported a change in their water use. And likewise, we saw really incredible efficiency there. If we don't mind going to the next slide. So I'm now going to hand it over to James Fazio. James is our CTO. He's also a founder of the company. And what James is going to talk about is kind of the evolution of these water data that we produce and what we're doing to more intelligently label that water use. And what that means is determining exactly where that water is being used, whether it's indoor water use versus irrigation, or even fixture level water use, be they washing machines, toilets, shower heads, etc. So he's going to walk us through that, and then we'll finally talk about kind of how that data or how those data will be manifesting themselves in our product in the future. So with that, I'll hand it over to James.
Yeah, thanks so much, Clay. And just kind of to reiterate what Clay has already said so far, at Flume, we've been really focused on three things since the founding of the company. And it all relates to water usage data. One is affordability. We've tried to create a product that we can get into as many people's hands by making a cost-effective product. The second one is accessibility. We want this data to be accessible to both the homeowner that's actually using the water and the utility that's providing that water. With accessibility too, we wanted to make something that was super easy to install. We didn't want to have professionals come in and have to install this. So this is actually something that anyone can install. And the third point here is the accurate and reliable data. Obviously, if you're presenting water usage data that's not accurate or people aren't going to trust, it's a poor user experience. So we've been really focused on making our devices as accurate as possible. When it comes to some of the more advanced topics, such as disaggregation, what disaggregation means is if you have, let's say, a day of water use, you want to break that day of water use down into events. Events could be like a shower or irrigation or a toilet. That's the actual act of disaggregating that overall water usage into separate events. It may sound sort of complicated at first, but when you have a really great, reliable, accurate data set, it makes that problem easier and easier. Kind of like a famous saying in the machine learning world is, it's much better to have a couple of engineers with a great data set as opposed to a sophisticated engineering team, maybe some engineers with PhDs in a very poor data set. If you have a poor data set, it's hard. You're making lots of trade-offs. You spend a lot of time sanitizing that data. So that's why we've been so focused on this really nice data set. And where we're at today, we've been spending a lot of this second half of this year focusing on indoor versus outdoor water usage. Flume currently collects water usage data at minute intervals, and we've shown that that is enough to actually disaggregate indoor versus outdoor water use. So if you could go to the next slide. So here's a graph. Let me kind of walk through what we're looking at right here. This is actually a single Flume user. This is a month of water usage. Each horizontal line represents a day. The usage along those lines represent usage events. So you can see the higher the usage event is, that means the more water that was used. Just eyeballing this, you can see throughout the day, and the morning is on the left, night is on the right. You can see a lot of sporadic events, and then you can see some events that seem a little more cyclical, happen a little more on time, like that event that's on the left. So if you could go to the next slide. This is our actual disaggregation algorithm going over this data. The green represents irrigation and the blue represents everything else. So as you can see, that makes sense, right? An irrigation cycle that happens in the morning. There also looks like a manual schedule is run in the afternoon on one of those days, while the rest of the day you can see those kind of smaller events, whether they're showers or toilet flushes or washer machines. If you could go to the next slide. Here's the same sort of idea. This is a different user, obviously a very different sort of month view here. People use water very differently. You can kind of see this sort of event that happens in the middle of the night. You can see something that happens in the morning and something that happens at night as well. So if you go to the next slide. So our disaggregation algorithm is actually good enough to notice that event on the left. That's actually a water softener, which can look like irrigation, but we've collected enough data to start to parse out stuff that looks like it could be irrigation with actual irrigation. If you want to go to the next slide. So here's a user that uses a lot of irrigation. I mean, this makes up, you can see that morning cycles, it's like 95% of their overall usage. So if you go to the one slide to the right. Yeah, that's a lot of green on that graph. Very important here. I mean, this kind of coincides with what we're seeing at the state level too in terms of legislation. People use water very differently. It's very important to have that distinction between outdoor and indoor use on sort of a per home basis. I believe we have one more here to show. If you go to the next slide. Here's another event. Same as the other graphs, you can kind of see these little events throughout the day. And if you go to the next slide, we get that irrigation labeled. So it looks like maybe a couple of drip irrigation cycles happened towards the morning, but then there's that sort of predictable nighttime irrigation for this user. And you can go one more slide. Here's sort of a real-time view. This is just a loop of viewing usage. Same sort of thing where the green represents irrigation and the blue represents everything else. So in this graph, you can see kind of clicking through the hours, seeing that blue usage. If you go back, you can see that daily usage over the month. You can see the irrigation in the morning and night. You can see that sort of non-irrigation events happening after the irrigation. So it's pretty cool. And this is sort of the first time that we've been able to get to this level of granularity. It's really exciting for the water space in general. You can go to the next slide. So 1 minute is what we're dealing with right now, 1 minute granularity. 1 minute data is great, and we're able to do this indoor versus outdoor disaggregation. Where we're headed in the future with our next sort of hardware release is the 5-second data. And 5-second data is a whole nother level. We really do think it's game changing. With 5-second data, we believe that we're gonna be able to disaggregate all water using appliances that a house uses, whether it's indoor or outdoor. So it really is the next level of where we want to head. And I think these next few graphs are pretty eye-opening. So if you could go one to the right, please. Here's a water usage event at the minute level. So each bar here represents a minute of usage. Looking at this, it's kind of hard to determine what's going on. It looks like something filled up and then it kind of settled down and then filled up again. But if you go to the next slide, this is at the 5-second level. It's almost like, you know, you're putting on your contact lenses and everything becomes more clear. You can see that initial fill up. You can see that pause. You can see then an additional fill up, which looks very much like a washer machine cycle. So pretty eye-opening. And I've got one more for you. So if you go to the next slide. Here's another event. This is 2 minutes. You can ignore the labels on the bottom. This is 2 minutes of water usage. You know, if you look at the total, looks like a flush. It looks like there's about 1.8 gallons of water usage here. Now, if we go to the next slide, at the 5-second level, oh man, that becomes really clear. That's a 40-second, 45-second event. You can actually see it kind of sloping off at the end. And from what we see, almost all toilets have a very similar signature to this. And we can go to the next slide. So just as a summary, where we're at today is at that 1 minute resolution. And like I was showing you guys before, we can reliably do indoor versus outdoor sort of disaggregation. We also are using machine learning in our leak detection algorithms. There's lots of events in the house that can look like leaks, like a water softener or irrigation itself, or any event that uses water for an extended period of time. We're actually able to filter those events out, so we don't notify the user saying it's a leak if their irrigation goes off, which is pretty cool. And where we're headed is that 5-second resolution. That's kind of like the holy grail of water usage right there. And we want to get to that full appliance disaggregation. So we want to be able to tell you how much your washing machine uses versus your toilet versus your shower versus everything else. It allows us to do things like faster leak detection, get even better than where we're at today. Another thing this 5-second data allows us to do is actually unstack events. And what that means is if a user has irrigation, but a shower occurs on top of that, we'll actually be able to dissect that out and label those events as their own unique occurrence, as opposed to jumbled up in one sort of event. We're also going to be taking a look at contextual learning, which means, you know, each home uses water use differently. There can be outlier events. So taking a little bit of a learning period when a user first installs to actually learn some of these unique events and better labeled that way. So the future is really exciting. We're already we're almost kind of blown away by the indoor versus outdoor disaggregation that we have today. And utilities are starting to take notice of this too. And Clay is kind of going to finish up this presentation by explaining, why do we even care about water usage disaggregation? Why is this even important?
Yeah, so if we can go to the next slide. So thanks, James. That was fantastic. So as we think about kind of how these disaggregation data manifest in product, of course, you know, we have this consumer product that it's accompanied by an app. These higher resolution data do a great job helping homeowners or ratepayers better understand that water use, do things like detect leaks. And when we kind of contextualize it, against the direct distribution programs that we run with utilities, it really does a lot to improve their relationship with their utility, get them to a place of reasonable water bills, ensuring that they don't have a leak that goes unfounded. What really excites me about the disaggregation data is what it allows from a utility's perspective in terms of customer segmentation. Today, the way that we're segmenting customers is, we're thinking about, efficient water users, we're thinking about high water users, kind of at different strata. These disaggregation data enable a future where utilities can look at a certain section of ratepayers and say, hey, these individuals are irrigating too much, or these individuals use high flow shower heads. Perhaps we can direct them to a relevant program. It does so much in terms of really kind of improving the prescription of that utility's engagement with their ratepayer. And then finally, by delineating indoor and outdoor water use, understanding how water is being used, it makes massive contributions to budget-based frameworks and the California efficiency framework. So we really see these data as being incredibly valuable in that planning context, and really understanding how water, or what water use will look like kind of going into the future, and how we can kind of more efficiently manage to budgets, both from that utility perspective and that of the homeowner. So with that said, if you don't mind going to the last slide here, Drew, we really appreciate everyone that's taken the time to join this presentation. Again, we love the Data Collaborative. It's something that we've been a part of for a long time, and really appreciate everyone including us in these discussions. So thanks again.
And Drew and Clay, it does look like we have 2 questions. I don't know if there's time left to answer those, but I'll let you, Drew, answer that.
Yeah, why don't we take that one question that we have? I think that sounds good.
Cool. Yeah, so I see one in the chat and one on the QA. I'll do the one in the chat first. Chris Toll is asking, how is Flume thinking about collecting ground truth labels for different water use events for training the algorithm? That's a really great question. So for people that may not understand what ground truth is, basically, when you're building out these machine learning models, you have to have a set of data that indicates we know for sure this event is this. There's lots of different ways of collecting this data, and we're employing a number of them. One is through our partnership with actual Orbit irrigation. So now Flume and Orbit users can connect the 2 devices, and through that we get a ton of ground truth data about irrigation cycles. So that's one cool way. Through our app as well, we have a sort of feedback loop that's optional. If a user does see something's wrong, they can provide feedback to us. They can help in the labeling process. In the future, we're looking at almost building out a sort of game-based system that users can opt into, where we will be showing them events with context that they can help label as well. So lots of exciting stuff being on that side. And there was another question about, does the customer determine which events are irrigation or machine learning? So yeah, currently this is all machine learning, where the user can actually provide feedback, but the actual initial labeling is all done via machine learning.
And then Drew, there's one more. Do you want me to answer that?
Yeah, go for it.
So yes, Flume is the device being employed by Department of Water Resources in kind of across the state to kind of understand disaggregated end use, how much water is being used indoors versus out. We can't share any specific updates relative to its rollout in the city of Folsom, which was the most recent, other than the data have been collected there. They're of incredibly high resolution, and we're really looking forward to that being kind of represented and communicated by DWR. But if you'd like to contact us for any additional information on kind of how that works, or are interested in disaggregation data, please feel free to reach out.
Awesome. Well, thanks so much, Clay and James. That was amazing, and it's really exciting to see the frontier of end user water data at the 5-second level is amazing. Just being able to individually be able to tell what device is using what amount of water and be able to provide that to homeowners is amazingly powerful. And so thank you for that. And really appreciate you, your presentation and kind of how this is playing into some of the state policy issues as we keep talking about. It's hard to manage what you can't measure, and you're measuring it at about as high resolution as anyone. So very, very, very cool.
Thank you, Drew. Thank you, everyone.